We know that f of x equals x squared is not a one-to-one function. How can we restrict its domain so that its inverse function is g of x equals x squared? What we can do here is we can try and look at the compositions of functions f of g of x and g of f of x. Now, if we look at f of g of x, that's going to be f of the square root of x. And so this is going to end up being the square root of x quantity squared. And we know that when we take the square root of x and square it, we end up with x so long as x is greater than or equal to 0, because when we're taking the square root of x, that's only defined for x greater than or equal to 0. So this works on the domain x is greater than or equal to 0. Let's take a look at g of f of x now. This is going to be g of x squared, which will be the square root of x squared. And there are values of x for which the square root of x squared is equal to x, but this is not true for negative values. And this is because when we take the square root of a number with a radical symbol, this means we want the principal square root, which is the one that's not negative. So if x is negative, we square it, we get a positive. We take the principal square root, we get a positive again. And that is a problem because we know that x is negative. So this only works when x is greater than or equal to 0. So because both of these are restricted to x being greater than or equal to 0, we need the domain here of f of x equals x squared to be x is greater than or equal to 0. This is the restriction we need for our function to make sure that the compositions work out.